Okay, so we will talk again about normal strain, but with a system of cables. Okay, it could be also a system of rods or anything, but let's say it's not very straightforward, like the dimensions that is provided is not in the same direction than the strain, the normal strain. So we need to do some little bit of calculation, and usually it's just geometrical calculation. Oops. So what we know is we know that the cable were 1 meter long, both of them, so 1000 millimeters. We know that the angle alpha on both sides is symmetrical is 25 degrees. And we know that the point A will go 3 millimeters to the right when the force P is applied. And the question is, what is epsilon in each cable? So what will happen, and I will make it bigger so we can really see it. What will happen is your point A will move there, A prime, and your cable will have a distance L prime, and we need to find that distance. So how do we do that? We will use that triangle. So this triangle will be, let's call that point B, okay? Oops. So we will have point B, point A, and we know that the angle there is 25, and we know that this distance is 1000, and we will have point A prime. This one is 3 millimeter. I know it's not at the right um, scale, otherwise we cannot see. And we try to find this distance L prime. Okay, so it's not a right angle. We have two options: cosine low and sine low. And if we look there, we have two dimensions and one angle. So probably cosine low is easier. What we need, we need that angle in the inside. So this angle inside will be 180 minus 25. So this one will be 180 minus 25. That will be 155 degrees. So we will use the cosine law to find L prime. So we will have L prime square equal the dimensions of L, so 1000 square plus the other dimension square minus 2 times 1000 times 3 times cosine of the opposite angle, so times cosine 155 degrees. Forget if you use degrees, have your calculator in degrees, and don't forget to take the square roots after because you have the square there. So when you get that, you get the L prime equal 1000, 2.7 millimeters. So now that we have the new dimension of the cable, don't forget that for the strain, what we need is a difference, is a delta. So we have epsilon equal delta divided by the L naught. So that will be 1000, 2.7 minus 1000 divided by the 1000, the original length. So epsilon equal, that's very easy, 0.0027 or 0.27%. So that would be your strain in each cable.